Hello, and welcome to my podcast, From Lotus Leaves to Self-Cleaning Surfaces. My name is Ruiqi. In this episode, I will discuss how the lotus leaf inspires self-cleaning coating, how this technology is used today, and what limitations and future opportunities it may have. At first, a lotus leaf may seem like a very ordinary part of nature. However, it has a special ability that has attracted the attention of scientists and engineers. Even though lotus plants often grow in muddy water, their leaves can remain surprisingly clean. This natural ability became the inspiration for what is now called the lotus effect. To begin with the discovery of the idea, we need to look more closely at the surface of the lotus leaf. When water lands on many normal surfaces, it spreads out and leaves the surface wet. On the lotus leaf, however, water forms round droplets. These droplets roll across the leaf instead of staying in one place. As they move, they collect dust and dirt particles and carry them away. The reason for this behavior is related to the tiny structures on the surface of the leaf. Although the leaf may look smooth to the human eye, its surface actually contains microscopic texture. These structures reduce the amount of direct contact between the water and the leaf. As a result, the water builds up and rolls off more easily. This is a good example of bio-inspired design. Engineers did not copy the color or oval shape of a lotus leaf. Instead, they studied a useful function found in nature and asked how that same function could be react on the manufactured materials. The discovery created an interesting engineering question. Could a building, electronic device, vehicle, or other products stay cleaner if its surface behaved like a lotus leaf? So the next step is the evaluation. After discovering the natural effect, engineers need to decide whether it can become a particle product. They must understand how the surface works, determine what material can recreate it, and evaluate whether the result is durable, affordable, and safe. Lotus-inspired surfaces can be produced through painting, sprays, nano-coating, and other surface treatment. Instead of attaching real lotus leaves to a product, manufacturers create an artificial texture or coating with similar water-repelled behavior. One example I researched online is an interior wall coating inspired by the lotus effect. It names it steel color lotusin. The purpose is this type of coating is to help building surface stay cleaner after exposure to rain. Similar ideas are also used in products such as Never Wet, which is designed to repel water and other liquids. Nano-coating technology have also been used to help protect electronic devices from the liquid damage. This example shows that the lotus effect has developed beyond a single type of building paint. It can be applied to construction, consumer products, electronics, and other industries. However, engineers must also evaluate the limitations. Several classmates asked what happens when the coating becomes scratched or worn down. This is an important concern because the performance depends on the condition on the surface. If the microscopic texture is damaged, covered with the contaminants, or worn away over time, the coating may become less effective. A surface might work well when it's new, but real products experience touching, washing, weather, heat friction, and physical damage. Because of this, durability testing is necessary. Engineers must determine how long the coating lasts and whether it can be repaired on the reapplied. And it's the last thing. The third part of the environmental, of the entrepreneurial mindset is exploited the opportunities. In this context, exploitation means turning the idea into something that creates practical value. Lotus-inspired coding may reduce the need of the cleaning labor, water, and cleaning mechanicals. On large buildings, this could lower maintenance costs and help exterior surface keep a clean appearance for a longer time. One classmate asked how the technology could be applied on a large scale. Paint and spray applications may provide a practical method because they can cover large and complicated surfaces. However, the coating must be applied consistently. Manufacturers also control the thickness, texture, drying process, and the connection of the material underneath it. Another classmate suggests using a coating in kitchen or on dish. This is a really interesting possible application, but I would say a kitchen coating would need to be safe for contact with food, resist to heat, and durable enough to survive repeating washing and cleaning. And other possible applications include the automobiles, I would say, like solar panel, clothing, glass material equipment, and the industrial mechanics. For example, a surface that collects less dirt may help solar panel maintain better performance. Vehicle surface could also become easier to clean. Still, the technology should not be treated as the solution to every surface problem. Water repellent does not automatically provide the complete protection against the corrosions, biological growth, or chemical damage. In some applications, Lotus-inspired technology may need to be combined with other protective materials. To conclude, the Lotus effect shows how observing a small feature in nature can lead to a useful engineering technology. The most important lesson for this one is that the nature can provide the inspiration, but engineers are responsible for turning that inspiration into a practical, reliable, and valuable solution. Thank you guys for listening to my podcast from lotus leaf to self-cleaning surface. My name is Ruiqi Hong. I hope this one helps you guys understand how a simple leaf can inspire new possible in engineering. Bye.